Hi guys, this is the homework tutorial for page 49, numbers 1, parts A and B, as well as numbers 3 through 9, okay? You're going to notice number 1 here, I've given an example, and of course if you read the problem in the book, 1A, for example, talks about, I think, a newspaper company, but what it boils down to is they give you two fractions and they say, hey, if you added these together or summed them, how much total of a fraction would you have? The interesting thing here is I've given you a sample problem of what I might expect you to do. Give you two fractions to add together, and I've actually drawn a diagram of how much each fraction represents. Now notice the total are the same size, but they represent different parts of the total. So dynamically, if we were to put these things together, it would be very, very picture-wise easy to state that it would look like this. Okay, now we have this 1/3 chunk here. Okay, 1/3 plus this extra 1/6. It would look something like this. Now the weird part about it is this. Recall that you can't really put two fractions together or two things together unless you have the same type of stuff. Remember that really lame example I used in class was with apples and oranges. I said, hey, you know, if I give you 2 apples and I give you 3 more apples, what do you have? And of course the response is, well, I've got 5 apples. But if I said, hey, I'll give you 2 apples and I give you 3 oranges, what do you have? I got a bunch of fruit. I can't necessarily put things together unless they're really the same type of thing. I can put them together, but technically it's really hard to do unless they are the same type of thing. So looking at this, yes, I do have this amount. And some of you might be looking at this and saying, wow, you know, that looks like half of this thing is full. Yes, the answer is 1/2. But how did we get that? Okay, well, you know what? I'm not going to draw a picture every single time I need to add 2 fractions in my life, because if I'm dealing with like 3/17, I kind of have a hard time splitting it up into 17 equal sized pieces, you know what I'm saying? So I'm looking at this, I say, okay, well, here's the interesting thing about it. You can put things together mentally very easily if they are the same size. And I want us to recall that when we talk about size of pieces, what we're really referring to is this denominator here. Now, a couple of side notes. Like, first of all, hey, the bigger the denominator is, then the smaller the pieces are. Because every piece has to be the same size. The more pieces you have, they have to be the same size, the smaller the pieces. So it's like saying, hey, would you rather have 1/2 of a dollar or 1/1,000,000th of a dollar? It doesn't matter that that denominator is 1 million. That fraction is extremely tiny. Okay? The other thing is this. I could put these things together if they'd been the same size. Is there any way that I could have gone back and split these up so that they were the same size as these? And I know some of you are thinking right now, sure, hey, take your marker and split it right down the side. Now we're talking about the same type of stuff. Okay? So I look at this, and the interesting thing is, now there are no longer 6 pieces over here, or 3 pieces, excuse me. There are 6. Okay? So what did I really do here? Did I change the amount that I started with? No. We still have the same area shaded in. However, out of 6 pieces, how many are shaded in? And the response to that is 2 out of those 6 are shaded in. What I really wanted us to see was this. 2 6, and even after doing the last homework assignment, we worked with equal fractions, is the same fraction as 1/3. So what were we really attempting to do here by making these the same size? We were attempting to make a common denominator. I see this now as 2 6 plus that 1/6 that we have. But now that I've got that written out, notice that those are the same. We have the same type of stuff. So hey, if I'm giving you 2 of these 6ths, and I give you 1 more 6, I hope that we have a grand total of 3 total 6, which of course, verified by this picture, would equal 1/2 if we simplified that fraction. Divide both of these by 3. They had a common factor. Okay, so this is a simplified form answer, but this is a really good example of what I'm asking you to do. So if we had said, hey, you know, skip the pictures, let's go back and look at just the fractional addition problem, here's what I'm really doing. I'm thinking to myself, hey, could I make both of these the same number? So I think, yeah, what are the multiples of 3? 3, 6, 9, 12, 15, blah, 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 blah. And then 6 would be 6, 12, 18. Here's one thing to consider. Could we have turned these both into 12? And the weird thing is, yes. So why would I make them both into 6? Let's admit it to ourselves. We're not necessarily lazy. Let's put it this way. We value our time. We don't want to put a lot of effort into big numbers when we can deal with smaller numbers. If I look at this and I say, hey, I can just double this 3. If I double the 3, though, I have to double this 1 up here. That's the rules. That's what they say. If I want 2 equal fractions, I have to do the same thing to the top that I do to the bottom. And this, In other words, it's how we got our 2 6 mathematically without having to draw the diagram. Now that being said, let's take a look at what I'm asking you to do on 6 through 9. Now these are slightly more complicated problems, not in terms of skill level, but in terms of the amount of time it's going to take you to commit to these problems. Now, what they're asking is which sum is larger. Hey, what you could do is you could draw a picture. You're going to be here for a while, and it's not worth it to draw a picture because it's just more effort than we need to put in. It's not very efficient. So here's what we'll do. Let's actually add them together and see who's got the bigger answer. Hey, you know what? That was a really good example because look what we're dealing with now. Now, this actually is number 6. If you're watching this video, yes, I'm giving you the answer. Now you have to do 7 through 9, but check it out. Hey, could we make these both the same size pieces? So think, what can we turn 3 into and also turn 6 into? Some of you might say, well, let's turn them both into 18. Hey, that works. Turn them both into 12. Hey, turn them both into, oh, I don't know, 600. See what I care. But what would be the easiest? Couldn't we just take this 3 and turn it into a 6? Okay, so my question is, what could you take times 3 to get 6? Booyah, right there. Let's double it. So just showing my work, I would actually rewrite the problem because I'm responsible, and I say, well, now 2 times 2 is 4, 3 times 2 is 6. Now I'm adding 4 of these 6, which is the same fraction as this, to 5 more of these 6, which of course 4 plus 5 would give us 9 total 6. Now going over here, I start to ask this question. Hey, is there a number that I could turn 4 into and also turn 5 into? Think of all the multiples of 4 and all the multiples of 5. Now 5s are easy. You go 5, 10, 15, 20, 25, 30, 35, 40, blah, 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 blah. But I'm looking for one that they actually share. They have a common multiple. And I know that, here's a trick for you. If I took 4 times 5, that's the same as 5 times 4. So what is 4 times 5 or 5 times 4? It's 20. I could turn these both into 20. Now I'm going to have to operate on them both. But let's do this. 4 times 5 would be 20, but I have to take the top times 5 also. Over here I could take 5 times 4. That'll scale it up into 20, but I also have to take the top times 4. So after rewriting this problem, we determined that this would be, well, 3 times 5 is 15. And of course, we knew we were going to get 20ths. We kind of engineered it to do that. But I'm adding that to now 4 times 4 is 16. 16 what? 20ths. Okay, so if I added 15 20ths to 16 more 20ths, we should have a grand total of 31 20ths. Now the question here was, whose is bigger? Okay, well, I look at this, and some of you might notice that 6 goes into 9 one time with 3 left over. That would be 1 and 3 out of 6 left over. And some of you are probably saying that's 1.5. Hey, I know I've got 1.5 over here. Let me ask you this. How many times does 20 go into 31? Remember, this is a division problem. 31 divided by 20. 20 goes in 1 whole time, so we have 1 whole. And how many would be left over? That remainder, we have 11. But check this out. That's 11 out of 20. Now, I cannot reduce this fraction any further, but I do know this. If that's 1.5, this is bigger than 1.5, because exactly 1.5 would present me with 1 and 10 20ths. So these are not equal. This one is bigger. So we determined that originally this sum was the larger or greater of the 2 sums. That's what I'm asking you to do here. Good luck to you.